Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zudi. Right now, I will be presenting for the first part of the presentation, which is the application of Industrialized Building System, or we call it IBS, uh, on a case study which our group has chosen, which is the twin one-story residential building at Kangar Perlis. So we go into the next slide. So for the first slide, it's about the concept of Industrialized Building System, or IBS. Um, for, as for the Malaysia's uh, construction industry sector, it has many problems. Among of the problems is the construction skilled workers shortage, which has become a global concern. Next, our industry also faces challenges in obtaining labor as well as retaining qualified employees, and we must rely on foreign workers to meet demand for trained workers. As the introduction of IBS, it has been recognized as a potentially viable approach for improving overall building performance in terms of quality, cost effectiveness, safety and health, environmental sustainability, and profitability. Next, we're going to the framework of IBS. The story of the IBS is start from when the government and allied business agencies have made several attempts to address the numerous issues in the construction sector. According to the Scottish Government's procurement agency, the conventional building approach is expensive and incapable of meeting the increasing demands. It has been criticized for failing to build effective teams. As, uh, as for the IBS is a building system made up of prefabricated components. The components are manufactured off-site and shipped to the building sites for installation and assembly once it has been completed. Next, the construction industry has begun to adopt IBS as a way of improving building quality and productivity. It provides less waste, fewer sub-materials, a cleaner and neater atmosphere, regulated quality, and reduced overall construction costs. Okay, uh, last, the IBS was a huge success for the construction industry in Malaysia, as well as globally also. The primary objectives that must be met are the acceleration and expansion of affordable housing of high quality in Malaysia. Many of us assume that one method of construction is still widely regarded as a conventional and safe option, despite incurring increased expenses and slower production capacity. Next, we're going to the classification of IBS in Malaysia. As we see on the slide just now, uh, it has 5 types of IBS component, which is we will talking and we'll go through one by one on the next slide. Okay, first we're going to the precast concrete system. As for the precast concrete system, it is the most often utilized group in the IBS. It has been used not just in the construction of building. It has been used also for the construction of infrastructure. Uh, then there are precast uh, there are precast concrete. There are such many types of precast concrete, such as columns, slabs, walls, beams, and permanent concrete formworks component. Next, we go into the steel formwork system. It is a low-level or least prefabrication IBS is a type of formwork. As we've seen commonly in the construction of building in Malaysia, we see that many use timber formwork system instead of steel formwork system. The benefits of using this steel formwork system, uh, it provides high quality finishes and quick construction with fewer on-site labor and material requirements. Next, we're going to steel framing system. So before that, I want to remove my webcam first. Okay, as we can see on the diagram, uh, it is the construction is using the construction of steel framing system is using the trusses for the rooftop. So it's not just trusses that being used for the steel framing system. It also has beams and columns for framing system also, for steel framing system also, which are commonly used in the construction of skyscrapers. They are often used in conjunction with precast concrete slabs, steel beams, and portal frame system. Okay, next we go into the prefabricated timber framing systems. The timber building frames and wood roof trusses are the products of the prefabricated timber framing method. The timber building frames have their own specialized market, where they provide a range of designs from the modest living units to construction needing high aesthetical values. Next, we're going to the block work systems. Uh, Commonly, the we've seen that the construction that the construction of building in our country using either concrete brick or red brick, red clay brick. Uh, so for for uh, for the IBS, it has the blockwork system. It has their own blockwork system. So the concrete masonry units and lightweight concrete blocks have changed the building process of employing traditional bricks in the construction of new homes. The difficult and time-consuming traditional bricklaying processes are considerably reduced by adopting this excellent alternative technique, uh, as what as what as what say from the experts. Okay, so right now it's about case study. That's all for my presentation.
Hello, Assalamualaikum. My name is Daniel, and for the next slide, I will talk about the case study of this report. Now, the building we choose is a twin one-story residential building, a part of a residential development project that is currently located at Lot PT 4727, Kawasan Pertubuhan Desa Batu Pertangkup, Mukim Chupeng, daerah Kanker Perlis. Now, the residential area is a project that was created by Perpaduan Kemajuan Ekonomi Negeri Perlis, PKNIPS, and it was built by QCons Home Sendirian Berhad. Okay, the next slide, I will talk about the features of the IBS components that can be seen on the building. Now, first is the precast concrete column. Precast concrete column is actually a column that are used to support beams for extra tensile and compressive strength to resist constructive stresses. Now, the load is actually distributed and the weight of the beam is supported by corbels. Now, the structural framework of the structure is composed of columns and beams. Now, the column itself is a load-bearing element in a building structural system. Next, I will talk about the precast concrete wall. The wall panels are lifted and put in proper places for the structure after the concrete is solid enough. Tilt-up construction is the term for this approach, and today's cranes are used to raise and place such walls, allowing the casting to be reused in single forms. Some wall units are made in factories where the shape, material, quantity, and finish may be more regulated. Now, the precast concrete beam is a continuous beam that are utilized where single-story columns are used to minimize the bending moment of the beam and hence its depth. Now, continuous beam can also extend beyond the column support, carrying smaller fall in beams and in betweens. Now, the suitability of IPS component used on this building is IPS component actually is most suitable for this building type because it's a landed residential building and many of them can be built efficiently at a lower cost and shorter time duration. Now, the components used in this building are suitable because actually it requires less more manpower to install in the building during construction, and is more flexible and modular compared to traditional methods of construction that actually requires a lot of more manpower, equipment, and other stuff. Next is the fabrication process. Now, the fabrication process of precast column and beams. Firstly, the columns and beams mold have been assembled and the measurements are within the required specification for the building. Then, before the construction of the panel itself, the casting panel, the level and flatness of the base mold will be verified. Then, the mold will be cleaned and a mold release agent is uniformly applied on the mold surfaces. The length and dimension of the rebar and pre-stressing strengths are verified against the design before they are placed into the mold. Now, before casting, a sufficient number of spacers of the suitable size should be carefully inserted and fixed. Now, before pouring the concrete over the mold, a concrete slump test is performed in order for us to confirm the strength and the quality of the mix meet the need safety requirements. A suitable curing period is maintained to ensure that all precast components are exposed to the same and appropriate environment. After that, before demolding can be done, cube tests are performed in order to ensure concrete strength, and then all the poles and beams from the molds will be released and uninstalled before lifting and transportation of the component to the job site. Next is for the process of precast wall. Now, before constructing the mold for panel casting, the level and level fitness of the foundation are checked. The mold dimensions are verified in order to confirm that they are within the established specifications that are required. Next, using removal or scale bars, the mold will be cleaned or removed of dirt and all mortars. The size, spacing, and length of all rebars are all verified against the design of the building itself. Now, the placement and securement of pre-stressing strands such as corrugated sleeve pipes, recesses, and fitting hook must be done appropriately. Then, casting, vibration, and compaction will be carried out during the final inspection. Now, at this point, the concrete spread is already leveled. During concretion, a power trowel or flood is utilized to provide a smooth surface finish. After that, observation will be done in order to observe proper curing time and the ideal temperature. After observation, now before lifting the component itself, loosen and remove balls and pins. For pre-stressed components, strands are also secured before lifting. Then after that, before moving to the storage, the condition of the final product and its dimensions are thoroughly examined. Okay, so for the next slide, my friend Zaiti will present it. This is all. Thank you.
Assalamualaikum, I am Zaiti Zafira. I want to explain about connection detail of IBS component on twin one-story residential building. It's about the design and implementation of joint and connector are the most essential consideration in precast concrete construction. Bolting, welding or grouting are some of the other options for creating a good connection. First is a column to base connection. It is the most cost efficient and simply used. The precast concrete column is manufactured with corrugated sleeve, then stuffed with flowable non-shrink grout. It must remain proper until the grout has hardened. Second is a pocket foundation connection. It is the most cost efficient and simply to construct. In situ concrete foundation is cast using a tempered box shutter to create that pocket. It can accustomate to support precast ground beam, for example, for big concrete back footings. Precast concrete column is inserted into pocket form in the footing. And third is a steel base plate connection. It is a type of steel used when an instant connection is required to make a narrow beam or wall be supported by the steel during a building collapse. The steel are supported the principle of shear friction. Is employed because of the pin connection within the brace frame. Second is a column-to-column connection. Cast in situ infill grout joint can create instant resistant grouted joint. The design are resist to applied structural force. It also can use as a pin or moment connection for steel bars. Third, beam-to-column connection. It have two types, which is visible connection and hidden connection. Visible connection is a cobble connection are used extensively, especially for parking structures, and heavy loads are transferred from beams to columns. It could be a shallow cobble employing a grouted sleeve connection. It can support the large shear force at the top of beam. About hidden connection is the cleat connection, the most common used connection for connect the beam and column. The steel billet connector also the most ordinarily used connection. Is a light steel threaded dowel to attach through the hole within the projecting billet to a bolted cleat. Next is a beam-to-beam connection. The nib at the primary beam is attached and the tie between the beam. And the last connection is a wall-to-wall. It have two types, which is horizontal and vertical joint. Horizontal joint about lapping is the widespread used in situ concrete and tie steel. As a welded wall connection, it can create a lap between two parts of a building or structure. is created by grouting a bar extending from one unit into the corresponding unit duct. Vertical joint is a vertical precast wall joint or used cast in situ type of joint. A horizontal reinforcing bar from a precast panel project into the joint zone where overlap or welded with another reinforcing bar. Embedding plate, bolt and weld can be used to connect the two of panels. About the procedure of installation IBS component on twin one-story residential building. First, excavation. Using tools, equipment or explosive remove soil, rock or other materials. It entails moving, trash digging, tunneling, tools and resources and underground construction. Second is installation of foundation ground beams. On the excavation, precast concrete pad footing are constructed. Third is erection of precast column. The footings are fast to the precast concrete column. Concrete is used to cast the joint connection. The columns are connected vertically with rebar in the center reinforcing the bond. Bolts connect them and the bolts are grouted. On the excavation, precast concrete pad footing are constructed. And next is installation of precast beam. The beam is anchored by a projecting rebar on the bearing pad of the column cobble. After that, the gaps between the tiles are grouted. And last is erection of precast wall panel, exterior and interiors. Between the skeletal structure, walls panel are slid into their designated location. To secure the wall, the space are filled with grout.
Hi, Assalamualaikum. I am Norafiza binti Mat Jali. I will continue part IBS scoring calculation for the twin one-story building at Kanga Perlis that we find from the case study of this assignment. First, we go to the part 1, which is structural element. For structural element, we have tunnel formwork system and precast construction system, which is precast beam and precast column. For tunnel formwork systems, the total area is 646.46 meters square times 2 units equal to 1292.92 meters square. For precast concrete system, which is use precast beam and precast column, the total area is 625.43 meters square times 2 equals to 1250.86 meters square. The total area for these two structural systems is 1292.92 meters square plus 1250.86 meters square, so we get 2543.76 meters square. For these two structural elements, it has the same IBS factor, which is 1. Next is for the coverage for tunnel formwork system is 1292.92 meters square divided by total area of two structural elements, which is 2543.76 meters square, so we get 0.51. For coverage precast concrete system that use precast beam and precast column, 1250.86 meters square divided by 2543.76 meters square equals to 0.49. So, for the total area for coverage is 1. For IB score for tunnel formwork system is 1 times 0.51 times 50 points equals to 25.5. For coverage of precast concrete system that use precast column and precast beam, 1 times 0.49 times 50 points equals to 24.5. So, the total for part 1 structural element is 50. Next, we go to the calculation of IBS score, part 2, which is wall elements. For wall elements, we have internal and external wall and use precast block work for both wall. The total length for internal wall that use precast block work is 26.18 meters times 2 units equals to 52.36 meters. The total length for external wall that use precast block work 2 is 42.3 meters times 2 units equal to 84.6 meters. So, the total length for both wall elements is 106.96 meters. For both wall elements, use 0.5 for the IBS factor. For coverage of internal wall, 52.36 meters per 106.96 meters, so we get 0.49. coverage of external wall is 84.6 meters per 106.96 meters, so we get 0.79. Total length for coverage is 1.28. IBS score for internal wall is 0.5 times 0.49 times 20 points equals to 4.9. IBS score for external wall is 0.5 times 0.79 times 20 points equals to 7.9. So, the total IBS score for part 2 wall elements is 12.8. Now is the last part, which is part 3 for other simplified for construction solutions. For this part 3, we have column sizes based on MS1064, beam sizes based on MS1064, wall sizes based on MS1064, door sizes based on MS1064, and the last one is window sizes based on MS1064. For all these part 3, the coverage is 100% and the IBS score is 4. So, the total for part 3 is 4 plus 4 plus 4 plus 4 and plus 4. So, we get 20 for the total of part 3. Now is the total of IBS score from part 1, part 2 and part 3. For part 1, we get 50, part 2 we get 12.8 and plus part 3 is 20. So the total IBS score is 82.8 for the twin one-story building at Kanga Perlis. So, these are the drawing of twin-story building at Kanga Perlis that we get from the case study of this assignment. That's all. Thank you from us.